Hello and welcome to the 9th, and you'll be glad to hear, penultimate tutorial in this series on trigonometry. It really has been quite a marathon. And I have to say, I mean, the last couple of tutorials I think have been quite tricky, right, with the talking about trigonometric graphs. So I apologize if they were not as clear as some of the other tutorials, and it may be that with those topics the best thing is to look at those tutorials and then just to practice examples. And once I get to the end of this National 5 syllabus, I'll try to do various past paper problems, and I'll focus on some of those trigonometric graph problems so that you'll get some more clarity on those topics if it wasn't terribly clear. So the last topic for trigonometry is trigonometric equations, and in this tutorial I'm going to show you how to solve those using a more old-fashioned method, which is the one I was taught many years ago at school, which is based on sketching functions to find solutions. And then in the next tutorial I'll show you the more modern method of solving it, which uses kind of a mnemonic, an aid to help you. And some people will prefer this method of this tutorial, and other people will prefer the method in the next tutorial. It just depends on, again, whether you're sort of a graphical person or more of a numbers person. So we're going to solve trigonometric equations, and let's just do this by example. So let's imagine we were asked to find the solutions to sine x equals a half for angles x between 0 and 360 degrees. Well, from our special angles, we already know that there is a solution to this at x equals 30 degrees, because we know from our special angles that sine of 30 is a half. But the key point is there's another solution lurking around, and to see that we can just make a sketch. And just to remind you, I'm going to be sketching sine, cos and tan, but remember from our tutorial a couple of tutorials ago, we motivated these graphs of sine, cosine and tangent, and I'll be sort of sketching these, and the more you use them, the more you'll get used to doing really quick sketches. So I'm not doing careful sketches for these trigonometric equation problems. You really just do a very, very quick sketch. So here's 1 minus 1. Sine always varies between negative 1 and 1. There's 360 degrees, 180, 90, 270. Here's the sine curve. Okay. And we know that there's a solution to this equation at x equals 30, because we're asked, when does sine x equal a half? Well, there's a half. Okay. And there's that first solution at 30 degrees. And the way that you can solve these problems sort of graphically is to use your knowledge of the symmetries in these curves, how everything is symmetric about these curves. So the way the curve goes up is just the same as the way the curve goes down. So this other solution here is like a mirror of the 30 degrees one, and will be 30 degrees from 180, namely at 150 degrees. So if you think of this plane here as a mirror for these two parts of the sine function, given we know there's a solution at 30, there'll be another solution 30 degrees away from this 0 at 180 degrees. So the two solutions will be 30 degrees and 150 degrees. So I'll just do a few examples and you'll get the hang of this. Let's say we had cosine of x equals, I don't know, let's say it was negative 0.7. Okay, So we're going to have to use a calculator for this one. I'm going to make a quick sketch of cosine. And again, let's assume, unless told otherwise, that it's between 0 and 360 degrees. So cosine starts at 1, goes through 0 at 90 degrees, bottoms out at 180 and comes back up again, okay? And minus 0.7, negative 0.7 would be this line here. So the solutions, when does cosine of x equal negative 0.7? The solutions are going to be here and here. And the point of sketching is to give you a sense of where the solutions are. If you need to use a calculator, it's going to give you one of the solutions for free because it's tabulated. So if I put 0.7 negative into the calculator, take the inverse cosine. Oops, calculator doesn't like that for some reason. Sorry, this is an old calculator. 0.7 negative inverse cosine. It tells me there's a solution at 134.4 degrees. And that solution is here, you see, because graphically we can see there's a solution between 90 and 180. And now, using symmetry, we can say, right, this part of the cosine is just an inverse, a mirror of this part of the cosine, so this solution must be the same distance from 360 as this solution is from 0. So the other solution must be 360 take away 134.4. So if I subtract this from 360, the other solution must be 225.6 degrees. And we can just check, we can just take the cosine of this angle and see what it gives. And yes, it's negative 0.7. Let's do another example. Let's say we have sine x equals minus 0.2. Okay, so just do a really quick sketch. Of sine x, again between 0 and 360. There's my sine x sketch, and 0.2 negative would be sort of down here. So my two solutions I'm expecting, one is a bit bigger than 180 degrees and one is a bit less than 360. And by symmetry, the distance of this one from 180 will be the same as the distance of this one from 360, just using the symmetry of the curve here. So to get the first solution, I can, now I know what's going to happen here when I do this, and you'll see something that is helpful to know. When I put 0.2 negative into the calculator and take inverse sine, oh, you see this calculator is so old that it really doesn't want to cooperate on a cold day. There we are. It tells me that it's negative 11.5 degrees. Now the calculator will tend to give you what's called a principal value when you ask for the solution of one of these equations. And it's actually trying to be helpful. It's trying to give us a value close to the origin. And this is a point that I mentioned very briefly in one of the prior tutorials. These sine and cosine curves go on forever. So the sine curve, if we went to negative angles, would just go on forever in this direction. And above 360, it just goes on forever in that direction. Same with cosine. And actually the same with tangent too. And the key point is that sine and cosine repeat every 360 degrees. So if I was to draw this curve going in this direction to negative angles, it would just go on forever in that direction, and the same over here. So the sine function just repeats and repeats and repeats, so does the cosine function, and it repeats every 360 degrees. So this solution that's given me here, is actually going to give me, if I add 360 degrees, it's actually going to give me the one over here. So if I add 360, it tells me that there's another solution at 348.5 degrees. And I can check by just taking the sine, and I get minus 0.2. The solution here I can actually find just by saying, well, the distance of this one from 360 will be the same as the distance of this one from 180. So if I subtract 348.5 from 360, it's about 11, well, it's 11.5 degrees. Add that to 180, and that gives us the other solution, 191.5 degrees. So these are the two solutions that we would be seeking for this equation between 0 and 360. Quite a tricky one, because the calculator wasn't really being very helpful. It was giving us an answer outside of the range that we really wanted. But because these curves repeat every 360, you can always add 360 degrees to bring your answer back into the range that you need if you get an angle from the calculator which is negative. Let's just do one more example. Let's do an example with the tangent function. Tan x equals, let's say, 5.0. Now the tangent function repeats every 180 degrees. You see, even within 0 to 360 it repeats. So the tangent function repeats every 180 degrees, and that's worth bearing in mind. It doesn't have any bound on its size. It goes between from 0 up to infinity, coming in from minus infinity through 0, back up to infinity again, and so on. Here's 180 degrees, 90 degrees, 270 and 360. And here we want to know when does tangent of x equal 5. So let's just say 5 is there on the graph. We would be expecting these solutions. The calculator is going to give us this one. To find the other, we just have to remember that the tangent of x repeats every 180 degrees. We can just add 180 to get this other answer. So if I put 5 into the calculator and take the inverse tangent, I get this angle, which is 78.7 degrees. And then to find the other solution, I just add 180, and I get 258.7 degrees. And again, I can just check. I can take the tangent, and indeed it gives me 5. So this is a sort of a method to solve these trigonometric equations, where you essentially make a sketch, you figure out roughly where the answers are going to be, so you know where to look. Unless it's a special value, you'll be using the calculator to take an inverse sine, cos or tan to give you one of the angles, and then you can use the symmetry of the curve to figure out where the other angle is, the second solution. And then you can always, as we've done, just check that that second solution is correct by taking the appropriate sine, cos or tan. So for example, we took cos of this to check it had the right value. We took tan of that to check that it had the right value. This was a slightly trickier example where the calculator gave us an answer outside of the range we were interested in. We wanted an answer between 0 and 360, and then we had to use an additional piece of knowledge that the sine and cosine graphs repeat every 360. We could add 360 on to get a solution in the range, and then figure out the other solution by symmetry. So that was the method that we were taught at school many years ago for solving these trigonometric equations using graphical sketches. In the next tutorial, I'll show you a more modern method based on a mnemonic, which is similar in spirit but looks quite different in application. So I hope this was helpful, and I'll see you next time.